This video will walk you through troubleshooting an F16 error on a WPC2, 1000, or 2000 standalone press control system, as well as a SmartPAC integrated with a WPC system. Whether the WPC is integrated with a SmartPAC or not, the top-stop circuit resides in the press control and will be troubleshot there. If the system is integrated with a SmartPAC, it means that one of the top-stop loops should be tied to the SmartPAC top-stop output contacts. The top-stop circuit of the WPC2 and 2000 originates at the pin number 79 with a 24-volt DC signal. If the circuit is closed, the voltage is pulled down to 15 volts DC. From pin number 79, the signal is either jumped to pins number 80 and 81 or connected to top-stop contacts on other devices such as the SmartPAC. Pin number 81 internally connects to pin number 49, where it leaves the board via the operator station cable to the operator station. In the operator station, pin number 49 connects to two normally closed contacts on the yellow top-stop push button. From the other side of the two normally closed contacts, the cable returns to the processor board pins number 52 and number 60. See the figure below. The top-stop circuit of the WPC 1000 originates at pin number 37 with a 24-volt DC signal. If the circuit is closed, the voltage is pulled down to 15 volts DC. From pin number 37, the signal is either jumped to pin number 38 or connected to top-stop contact on another device, such as the AutoSet pack. Pin number 38 leaves the board via the operator station cable to the operator station, where it connects to two normally closed contacts on the yellow top-stop push button. From the other side of the two normally closed contacts, the cable returns to the processor board's pins number 30 and number 41. See the figure below. The steps you will need to take when troubleshooting the top-stop circuit are to inspect top-stop terminals for broken and loose wires. A connector screwed down on the wire insulation can cause an intermittent connection. You can then measure the voltage through the circuit starting at the drive pin and see where the voltage drops off to find an open in the string. Lastly, if you are still not able to find the open connection, perhaps it is due to an intermittent connection that the meter is too slow to detect. You could jumper out the top-stop terminals to see what jumpers clear the error. Remember, the indicator LEDs on the board can also be used to indicate whether the top-stop inputs are receiving the signal they need to be satisfied. To troubleshoot the top-stop string using a digital voltmeter, you can measure voltage and step through the string starting with the drive, pin number 79 on the 2 and 2000, or pin number 37 on the WPC 1000, with the black lead of your meter on a ground pin. On a good, closed string, you would measure 15 volts DC. If there is an open in the string, you should measure 24 volts DC. For example, if you were troubleshooting a WPC 2000, and you started on pin 79 and saw 24 volts DC, you would know there is an open in the string. You then continued on to 80 and 81, where you saw 24 volts as well. Then, when you measure pin 49, you see 0 volts. This would indicate that there is an open between terminals 81 and 49, which, if you look at the drawing on the top-stop string on slide 3, this is an internal jumper on the board. Perhaps the etch on the board got damaged. You could fix this by placing a jumper between terminals 81 and 49. Likely, you would have power up afterwards and your error would be cleared. To troubleshoot the top-stop string using a digital voltmeter, to ohm out or test continuity and step through the string testing each connection as you go through the string pin to pin. On a good, closed string, you would see continuity, or a low ohms reading pin to pin as you test each set. As in the previous example, if you were troubleshooting a WPC 2000 and you started on pin 79 and measured ohms on 80 and 81 and saw low ohms and then saw an open on pin 49, this would indicate that there is an open between terminals 81 and 49. You could fix this by placing a jumper between terminals 81 and 49. Likely, you would have power up afterward and your error would be cleared. Lastly, if you are still not able to detect an open or the cause of the F16, you can try jumping out the entire top-stop string by powering down and placing jumper wires across pin numbers of the top-stop terminals shown previously. For the WPC2 and 2000, this would mean inserting 5 jumpers across the 6 top-stop circuit terminals, and for the WPC 1000, it would involve inserting 3 jumpers across the 4 top-stop circuit terminals. You would then power up the system and see if the error clears. If so, then there was likely an intermittent connection. You would then power down and remove 1 jumper at a time and power up again to see if the error returns. If so, then the jumper that you just removed was the cause and you should inspect the 2 terminals that it jumpered together to find what they are connected to. For example, the top-stop button or a top-stop loop connection. If you have the entire string jumped out and still have the error, it is likely being caused by a bad input on the processor board, and that board will need to be repaired or exchanged. If you have a press control that is integrated with a SmartPAC, you can view the status of your top-stop inputs from the input status screen in the main initialization menu. From the main initialization screen, select Press Control, then select Input Status. Lastly, select F3 or eStop/TopStops. This screen will display the status of the top-stop 1 and 2 inputs. On means they are being made, and off means they are not satisfied. If you have found a bad connection or some other possible cause of the F16 error, be sure you have removed any troubleshooting jumpers. Next, prove that the error is cleared by powering up and verifying the F16 error does not appear. Stroke the press an inch and see if the press makes a full cycle without stopping. If so, then turn the stroke select switch to single stroke and try to cycle the press. You should be able to get a full cycle without any faults. For further assistance troubleshooting this or other fault codes, please call 800-586-8324 and select option 2 for technical support, Monday through Friday, 8 a.m. until 5 p.m. Eastern Time.